Welcome to this first ITDevCon hands-on session, which will focus more on the Delphi ID and editing and code than on slides. So I have about 10 or 12 of them only, and they will be only used as a background. Today's topic is practical application of OmniThreadLibrary. And the idea is that this session is structured so that I will present a simple problem, because if I want to present a complicated problem, we run out of time before I stopped presenting the problem, and then I will show a solution as much as I can do it in real time here. Something I have prepared in advance, some things I will do as I go. I think most of you know what the OmniThreadLibrary is, so I'll be quick here. I try to present it as VCL for multithreading in context where I think of tthread as an old good Windows way of doing programming when you wrote a big message processing loop and did everything inside. That's tthread. OmniThreadLibrary is the VCL way. Drop the module and use it and connect it to other modules, and you'll get a solution at the end. Open licensed, you don't have to pay anything, you don't have to release your sources, you don't even have to credit me. So it's completely open, it's OpenBSD license. Actively developed, I just released XE3 compatible version a few weeks ago. It's available from Delphi 2007. At the moment it only works for the VCL. It will most probably be adapted to work with FireMonkey on Windows soon, but OS X is a big problem, so I can't give any plans on that yet. The idea is to have it ready and running on all platforms, but it is not a simple job. It does work on 64-bit. So how do you learn more about OmniThreadLibrary? Last time I spoke here in Verona last year, I had to say sorry, but there's no documentation. This year I can offer you a book. It's a work in progress, still being written. When you can download it, you can buy it. If you buy it, you'll get all updates forever. As long as I continue to update the book, you'll get everything for free. Yesterday I had it outside the Smart Mobile Studio stand, so you could check it out. Today it disappeared somewhere. We don't know yet where it is, but feel free to come to the Smart Mobile Studio table later. Maybe we'll find it. It's limpub.com/OmniThreadLibrary. The code is available on the Google Code. It has a home page with all these links. The book is also available as a wiki with free access, but it usually lags a chapter or two behind because I have to find time to update it separately. And there's a forum for support, and I'm answering OmniThreadLibrary questions on Stack Overflow, and you can contact me directly. First problem, which is indeed incredibly simple, but again incredibly useful, is this. I have a long running operation in my program. Web downloads, database updates, some long processing, and I want to push this into background. That's simple to do with tthread also. And I want to be notified when the process is complete. That's also simple to do with tthread. So in this example, OmniThreadLibrary will give you maybe a little bit of syntactic sugar advantage. The code will be simpler. You wouldn't have to write a tthread descendant and so on. So I have a process that's initialized and then takes a long time to execute. So much time that the user interface is blocked. in the meantime, and the user notices it. And then I want to do some cleanup. Okay? So my example here, I have prepared a very complicated program which does the best payload possible if you want to demonstrate a blocked user interface. But there's some preparation. I'm updating the button, disabling it, and then I do this long stuff, and then I want to enable it. We all have such code, which is not sleeping but doing something in old programs, but then the time comes when you want to execute it more than one time at the same time, or you don't want user interface to be blocked anymore. So what to do? Well, you want to push this operation into background. In all my drawings, this orange or whatever line signifies a thread separator. So this is one thread, this is another thread. And at the end, you want to do some cleanup. The OmniThreadLibrary way is to include a unit called OTL parallel, which contains high-level solutions, design patterns, or abstractions, as I call them. And then you say, please execute, initialization stays the same, of course. We don't have to force the update because we'll not block the main thread here. But I say, please execute this in the background thread, or actually even this should work. And it's async, sorry. And at the end, execute this code for me. And you're done. It looks simple, but lots of things are happening here behind the scene. So when you call async, a new thread will be either created or allocated from a thread pool, which is waiting in the background and keeping your threads alive, so you don't have this long startup time when a thread is being created. Then this method will execute in the background thread. And after, if it's done, it will send a message back to the main forum, where it will be caught by a hidden window which was created here inside. And this message will be processed, and it will execute the finalization, the cleanup code, again in the main thread. So this will execute in the background, this will execute in the main thread. And if I run it, you can see I can move everything around, even if it's sleeping. I can even set more than one button to run the same code. Toof, 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 they're done. So, and do you believe me that it's running in a background thread? Or do I have to prove it? Yes. Prove it? Okay. So let's do the breakpoint here. And let's do the breakpoint here. So now we are, oops, I hate this. Now we are in a background thread called parallel.async. It will sleep 5 seconds. I can click again. Now I got a new background thread because the first one is still working. And now the cleanup code is executing in main thread. And if I click this again, let's try the third button. I'm reusing the thread from before, and the other thread is now idle. It says idle thread worker. It changes the name for debugging so that you can follow the flow more easily. So that was the simple part. Something a bit more complicated, still very easy to do with tthread. Again, you want to run a long running task in the background, but this time you want to process the result. Maybe it's a calculation that gives a result, or in my demo, I'm doing a HTTP GET, and I want to filter, process, display the page that has been returned. And I'm using the normal what is called WinHTTP, which is synchronous and runs in the thread that called it. So I have this stupid program, clears the memo, retrieves one page, gets the page contents, oops, again, I have problems with this small resolution, sorry. Retrieves the contents into a variable and assigns it to a memo. And this HTTP GET is intentionally implemented by using WinINet, which is synchronous. Very simple, well, not very simple to use, but simple to use, and it works with default proxy settings on the Windows machine, which is sometimes quite helpful. So this program, this was blocked for a moment. Okay, it doesn't move. Then I get my long table. I choose a document which is very long, so that's easier to demonstrate. Well, in the OmniThreadLibrary, this is done by a concept called future, which is a well-known technical terms for background operation which can return a result sometime in the future. It's documented on Wikipedia, for example. And the whole thing, again, works by pushing the calculation into background, but also by providing a channel which returns a result. So, but the problem now is, when do you get this result? Well, when it's ready, but when is that? Well, one idea is that you can do some other work and then just simply fetch the result and block if it's not ready yet. The other approach is to try from time to time if the result is there. Depends on what's simplest to do in your code. They're all okay. And the third one is to get a notification back to the main form, similar as in the async await case. And then when this notification is received, you just fetch the result because it definitely is ready at that time and process it. And that's what I will do here. So again, we won't need the update because the user interface will not block. I will create something called a future, background get, for example. It's OmniFuture returning a string in our case. A future can return any result you need, and the generic system is used to give you type safety so that everything works nicely. Again, I will need OTL parallel. And I will say there, this field will hold my future, which is of type string again. And this future must execute a function because it has to return a result. So it's function returning a string, of course. I'll just wrap the same call I have before. And then we'll do something about the results. So let's keep this away for a second. We need this variable now to be local. Oops. So again, this will execute in a background thread, return a result. And we have to do something when this calculation terminates. So the way to do it in OmniThreadLibrary is to set up task configuration block, which is a way to set up responders for messages. We'll see this later. In this case, I want something to execute on termination. And on termination, I will simply so I don't have variable accessible anymore at this moment, but I do have my future, and I can say give me my value back. This is the call that will block if the value is not available yet, so if this did not return, and it will give me stored copy of the result if it is ready. And I will also have to clean the memory after me, so I don't need this future this is an interface, I don't need it anymore. You'll see me in my demos I use anonymous functions a lot, but this is Delphi, so I could also change this into a normal, or I could change this, for example, into a normal method. So you don't have to use anonymous functions, but they're available for you. If you went to the Jeroen's session yesterday, I'm actively using Modern Maker, Code Explorer, and GExperts in my work. So something is wrong. Of course, we don't need this anymore. Now I can start the calculation. The form is responsive, and I get the result back. It's quite similar to the async await. We are executing something and doing something on termination, except the syntax is a little more long-worded in this case, because the future has many more possibilities I'm not showing here, but they're documented in the book and in the wiki on the web, so you can look it up there. Well, now we are moving to more complicated stuff. How do I run a background operation in same operation, same task, in multiple copies, processing some stream of input, not one piece of data, but some queue of data, a list of elements, array, whatever. So I have something going in, I have some process running on this data, and I want to get some result out of this. And in my demo, I set up, let's switch. So all this code will be available for you. I set up a program which retrieves a bunch of links from the web and marks each one with plus when it's done. So imagine here a nice grid when check marks appear on the left, when a link is fetched and so on. But this is a demo code. And in this serial version, it works by having an array of page IDs, and then it puts together Delphi feeds URL, and it has a, where it is, it's message triggered. So on create will post a message back to self, sending two parameters, current URL to be fetched and the highest. And this message processor will get the page, put it into the memo, add the plus on the left, process messages, so, or otherwise sometimes things will stop, and I have no idea why, because it really should work without that. But I've hit some Delphi X2 problem here. And then it will tell itself, get the next link from the list. This is typical message-based Windows program. So retrieve page responds to this WM retrieve message. OmniThreadLibrary, you use something called background worker. Basically, you can think about it as a client-server solution. You start a farm of computing engines, processors, a code that works on something, and then you send work items inside. So you say, please do this operation on this data. And this computing engine, the first idle processor will grab it, will process it, and it will spit out a result which is whatever you provide as a result again. And this is always, every process is running in a different thread. The messaging is actually unified. There's only one channel in, one channel out, but I have problems to draw it in the PowerPoint. So that's why there are 2 arrows. And this one will take a bit more time, but should be still quite simple. Again, we need the all-powerful OTL parallel, and we'll need the background worker, because it will have to stay alive for some time. It will have to stay running. We'll start it, we'll start. We'll stop it, we'll stop. So if I do the stop first, well, this Windows message-based solution had a Boolean field called stop, which was set when I clicked stop. And this would interrupt the message flow. So if stop was clicked, next get would not be triggered. We would not need this anymore. But we'll need this background worker, so it's parallel.background worker. We'll see later what we need. We will need notification when a work item is processed. This is called onRequestDone handler. And we will need a code that executes each request, which is called execute handler. And by calling execute, I also automatically start it. Oh, sorry, I'm writing start code. I need to write stop code here. So to stop it, to stop it, I call terminate. I'll wait for it, and I'll destroy the interface. That's simple. To start it, I will create the interface, assign the request done handler, and assign the method that will execute inside here and here and here and here. Actually, I have a 4-core hyper-threaded machine here, so I could start 8 tasks easily. And that's what happens by default when you use background worker. It will try to use all cores on your machine. I can also say, okay, this is HTTP GET, which uses very, very little CPU time. So I can start more copies of this process than I have cores. I say num tasks. Well, how many cores are there? Okay, I will need a helper unit. OTL common. I can do environment.process.affinity, which will give me number of cores available to my process, multiply by 2. And I'm starting twice more. It's as easy. And on execute, let's say I will execute the new function retrieve page background, which is not written yet. And I will come to the request done handler later. So we need this retrieve page background. It will receive one parameter, which is of type tOmniValue, which is something like Delphi's t-value, but this was introduced in 2007 when there was no t-value, so I'm still keeping it around. In some ways it's more powerful than t-value, and in most of usages it's quite faster than t-value. And you can also assign it to a t-value or assign from t-value, so it's not a big deal for using it. But you can think of it as some kind of very specialized variant type. And this, sorry, it's not tOmniValue in my case. Oh, I was skipping ahead, sorry. So this execute, it must have a signature not t value, but work items, sorry. And the work item in turn contains a data, which is something you send in, and this one is the omni value, and returns a result, which is something that comes out, and is again the omni value. You can store a record inside the omni value, or you can store a class. So if you want to say, if you want to send or receive a complicated data, you just pack it some way, put it in this one variable, and off it goes. So, yeah, so an on request done, let's say, needs I'll write this one in place. This one receive a sender, so you know which background worker, if you have many, has sent you the result. And again, you get the work item. In my case, okay, we'll see what we'll do. So at the beginning, the code, at the start click, the code fills my list box, and then it will not start the message loop, but will create the background worker, and then again it will say, for every link that I want to retrieve, I need to start a workload. So I need to schedule something. And what I schedule is a work item, the one I just shown you. And to create a work item, you call the create work item function, which will accept your input, whatever it is. In my case, let's just say I will send in this same index. And that's it. This code will fill up the input queue. You can also generate this while the background worker is processing, while the code is executing, and so on. I'll just push everything in at the beginning. So the execute, the retrieve page background, will receive this number in the value in the work item .data. And he has to do the same thing as here, except that we will get this from the data, which was string. So I put the string in. This is sorry, this is integer. No, this is string. My bad. I have to send. So clinks is array of the pages I want to retrieve. Clinks indexed by ilink is one page name, which is a string, and this is automatically converted into the omni value. And when I pass this back into a function accepting string, it will automatically get converted back to string, so you don't have lots to do. Of course, I cannot assign it to a memo, because you must never access VCL controls from a background thread, never. It will not work. It will crash your application. It will cause you problems. But what I can do, I can return a result. I say work item result becomes the omni value dot create, because I want to return two things. Okay, I'll change the code again, sorry. To make it simpler later. I will just send the integer inside. I will access the array here. This is thread safe, no problems. And I will send back this same index so that main program will know what was processed, which page is this that we are returning the data, and I will return page contents. Okay, and this time I have to explicitly say this is integer because this is a variant array which accepts anything, and in this case Delphi doesn't know how to do the automatic conversion. So this, well, okay, in this case I have to do it too. It depends on the compiler, what it will do automatically, what it will not. So I'm getting back this array of 2 values here, so I can do memo1. I think I pressed F1, so we'll have to wait a little. So I will access work item.result, the second element, and put it into a memo. Memo1.text becomes work item, 1. The first element is 0 index, the second has index 1. And we have to mark it as loaded, but I can simply call the old code, which helpfully accepts the index that was loaded, which is work item 0. Work item.result, of course. And if I start now, and the pluses appeared all over the place because the code is running 16 tasks at the same time, and they just fetch everything. I can hardly stop it before it's finished. No, I cannot do it. So maybe this way, yes, with the keyboard. So the terminate canceled work items in progress. It stopped everything, and it's lying now idle, waiting for us. Next part, and there's where stuff gets complicated and interesting. Sometimes you cannot start multiple copies of an operation because the operation itself is not written in a way. Typically, you're storing the stuff into the database, you run into problems if you run more than one copy, or I don't know, whatever. You access file system, you write to one file, you don't want multiple tasks to write to the same file all at the same time, because you're running into problems. But lots of times you have processes which can be distributed into stages. And what I have here, partially implemented already with the OmniThreadLibrary in mind, because otherwise that would take too much time, is a web spider. A process that I give a URL to. It will fetch the page, extract all internal links because I don't want to complicate too much, and then put those links back into the queue so they are processed again. What I also want to do is update the user interface so I know what was processed, and I also want to store every page into the database so I can watch it later, I can retrieve it at will. Well, I will not do that, I will just write a comment, store into the database here, because we don't have time. But you'll get the idea. And I can split this into 4 stages. Stage 2, and I'll leave this undefined for a moment, is web page retrieval. As we've seen, I can do multiple copies of HTTP GET at the same time, no problem. Stage 3 will store results into the database, and to keep this simple, I will run only one copy of this stage, so I don't have to synchronize, I don't have to open multiple database connections and so on. Anyway, this is very fast, this is very slow, so one copy is completely enough. I will also update user interface at this point, because this is nice, single point in time. I can say, okay, it is stored, now I can display the information on the interface that it was stored. Then stage 4, I will run HTTP links extractor, and I will push all internal links so that are on the same hosts, on the same subpage, back into the queue. And here, stage 1, I will run a simple unique string filter so that I don't process any URL more than one time, because first page will link to second page and second page will link back to the first page. I don't want to process the first page again. So I will have one copy of this one, because this is again very quick t-string list lookup. Multiple copies of web browser, webget, HTTP-GET, one saved to database, and one or two maybe. This is something one would test in practice, what works the best. Link extractors. And the way to do it with OmniThreadLibrary is a pipeline, which is a well-known concept used in computer graphics. Every graphical chip inside your notebook will do pipeline internally to process your images. Pipeline concept abstraction in OmniThreadLibrary will automatically again generate threads, put your stages, as I call them, into appropriate threads, and will provide input-output channel for each thread. And it will also automatically connect stages with one with another. The connection here is done with something called iOmni blocking collection, which is a very fancy first in, first out queue with two good properties. One is that it's completely thread safe. You can run multiple readers and multiple writers at the same time from as many threads as you want. Everything will work. That's why I will be able to write this stage from main thread and also from the last stage thread without any problems. I'll just be reusing this input channel from both points. And the other is that it has a blocking enumerator. So when I'm processing data in a pipeline, it can quite easily happen that this stage, for example, the database storage, will run out of work, because all those will be busy getting the web pages. And it must somehow wait for work to appear, but it still has to be able to stop when I want to shut down the whole pipeline to stop everything. And the way you do it in OTL is that you just write a numerator here and you say for value in this input pipe. It will work while there's data, it will process it. If there's no data, it will block. It will not take any CPU. It will just wait for an event. And when the data appears, it will start working again. And when I want to shut it down, I will say here on the input, this input queue is now completed, which means it already received everything that is to be received, no more work for you. And when this happens, this stage will process everything that's in the queue, run out of work, it will see, okay, it's completed, and it will do the same on the next queue. So it will mark this one completed, that one will mark this one completed, and so on. And another nice feature of pipeline, which I will not be using here, is that if exception occurs at any stage, it will be caught and it will be passed to the output pipe. The exception object itself is transferred over the queue. In the next stage, if you want to process exceptions here, you can do it. If not, it will automatically raise exception again and it will go through the system and you'll get it in the main thread when you can react to it. So it helps a lot if you write the complicated stuff. So as I said, this time I'm cheating a little. I don't have a single-threaded solution because it's too complicated. I have half-written OmniThreadLibrary solution. So I will put in OmniThreadLibrary homepage and click Start. So when you download the code, you will see there. It's hard to see, sorry. For example, I have this webspider.path, which is partially complete it, I also have wetSpider-parallel, which is the full version, so you can examine it in peace and quiet of your home or office. Same for the previous example, the link retriever with background worker. There's the single-threaded solution and multi-threaded solution -parallel. So this is the better one. As I said, this one is half ready. I'm using already any OmniThreadLibrary unit I will need. I have this iOmniPipeline field declared, but not created. So to start it, I will say like fspider is again parallel.pipeline in my case, and I need one stage which is unique filter, one stage which is HTTP GET, one stage, these are just names of methods in this code, one stage which is store to database or something like that, yes, store to database, and one stage named extract links, and I have to run it, and then I have to start the initial work somehow, where I will simply say, for starters, please process the root page. As I said, every stage has an input and output queue, but the whole pipeline as a complete abstraction also has an input and an output where the result comes out. And I can push something to the input, and this will automatically start processing along the whole pipeline. At the end, I'll do fspider.input complete adding, which means I will not add any more. My input is complete, process what is there, and then stop. And I'll wait for it, which will not take long actually, and again I'll clean up the interface. Okay? And I said I will need, by default, each stage runs only on one thread. But I can say, okay, I'll need this one in one copy. This is not needed, but it will look better if, when I start saying how many tasks there are, if I'm explicit for each stage. It's better self-documenting. I will run multiple HTTP gets, but this time only as much as I have cores, because I have other things to do in this program. One database store, and let's say 2 link extractors. I think this should compile. Yes, it's not working yet, but it compiles. Well, now the stages. The stage code, method, anonymous method, whatever, they come in 2 forms. They either accept input and output queue, or you can just say, give me input data, I will provide you with output data, and the OmniThreadLibrary makes the wrapper around it, which processes input queue and generates data in output queue. I will show both here. So the first one is the unique filter. It receives the input queue and it puts data into output queue. It will create a t-string list. I will need the queue data, which is again t-omni value. Everything is OmniThreadLibrary is t-omni value. And I say for value in input do. That's what I was talking before. This will process data. If there is data, it will wait. If there is no data, it will stop when complete adding is called. And when it stops, this code will exit, and then parallel pipeline infrastructure will automatically close the next queue, and it will just cascade through the chain. And here I can say if my string list does not contain yet my URL, then I will add it to the list. Again, everything is automatically converted into string. Is less than 0. And I will push this into output queue for further processing. I could use add here, add element to a queue, but I'm used to use try add. The difference is if you try to add element into a queue which was already completed as before, which is stopped, then the add function will raise an exception, and try add function will return true false result. And in this case, I really don't want to have any exception. If by some chance the output queue is already closed, it only means that everything is shutting down, there's nothing more to do. I can simply fail here. Nothing will be added, but I don't need to handle it in any way, because next moment this will also exit, everything will exit. So I'm getting input URLs. If the URL is not in the table yet, I will add it and I will put it into the output so the HTTP GET processor start working on it. The HTTP GET handler is of the second kind. It already receives input value and produces output value. So I don't have to write this enumerator and everything. What I will do, I will again use this HTTP GET. I don't have my URL here. We'll send this input as string, but this will happen automatically. And I'm also handling HTTP GET failures. If the page couldn't be retrieved, if the link is broken, I don't have anything to put to the output queue, and I will simply do nothing. If the URL was retrieved, I will create output element containing two items. Before you've seen I can pass an array, and then I can index it by integers. I can also pass a named array. I can say I was retrieving this input, and I will need, this is open array, so I need square brackets here. I got this content. I will need both if I want to store this into the database. I need the key, which is the URL. I need the data, which is the page content. So I need both. I pass them both on. The store to database runs in one task. It would open the database, close it at the end, and again it would implement a loop. The rule of the hand here is if you have to do some initialization and cleanup, like with string list in the unique filter or here with the database, you write this version of a stage with loops manually, explicitly, sorry. But if you don't need any initialization and cleanup, you simply run the simple version, which gets one item of data and optionally produces one output item. So I would store into the database here page URL and page content. I will also push, but this time only the content part, into the output queue so that it will be processed by the string extractor stage. And I said I want to notify the main program that this was stored at this point. So I will use this task parameter, which is optional, which gives me communication interface. back to the main thread, and I can say task over communication channel, please send a message. This is asynchronous messaging. I don't care about message ID because I will only have this message type. And what I want to say send is the URL. So the user interface will say, okay, this one was loaded, is stored in the database. But I also need something to process this message. And if you remember before, I run task config with onTerminated. Here I will specify a message handler. I can say all messages will be processed by the form, and then I write Windows-like message handler like procedure blah 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 semicolon message ID, and it will get dispatched. I can put everything into one message handler, or I can say explicitly I want message 0 with ID 0 to be processed by this show stored method, which I already have. This one will execute in the main thread so that it can update the user interface and everything. I have one ready here. It will receive something called OmniMessage, the OmniMessage, which is a record and contains message ID, which we'll know will be 0 in our case, and message data, which is whatever we have passed inside. Okay, and as the last thing, we need the link extractor, which is already written. It gets one input value and optionally produces one output value, but in my case it will not produce any output. It will just extract links, and for every link which does not start with HTTP, it will say, okay, this is internal link, please push it back into the global input queue. And I think this is all.